as these problems get a bit harder, we are going to need an extra skill at our disposal. This skill is called the commutative property. In this case, the commutative property of multiplication. And I have a cute way of remembering it, right? This is sort of how I was taught. Commutative is like commuting, okay? So if you were to commute from, home to work, it would look a little something like this. First you were at home, then you moved to work. And the key part of this is the movement, right? The change in location. So first your car was here at home, and now your car is over here on the other side of the work building. That commuting, that movement, that change of location, that's the core of the commutative property. So how does that work with actual math? Let's say you have something like 3 times a times 9. Well, you want to simplify it. What are you going to do? You're going to move that a, boop, right over here. The times a scooches over, and then we can simplify, and we can say, okay, now we have 3 times 9 times a. Yes. Then you can use your associative property if you want. You can have 3 times 9 associate with each other. You're going to get 27 times a, or just 27a, right? That's the idea. Now let's do it with something more complicated and exciting. Here we have 4b to the 6th times 6 times b squared, right? And first we're just going to go ahead and do a bit of multiplication. We're going to break this up a little. So 4 times b to the 6th times 6 times b squared. Okay? So, multiplication form for those two terms there. And then with this, we're going to commute twice. The first time, this 6 is going to commute over to here. The second commuting, that b to the 6th is going to commute over to there, all right? The idea, by the way, is that you want like the normal numbers, like 6 and 4 and 7 and 3 and 9 and whatever, 12 and 186, doesn't matter. Those normal numbers, you're going to want to like kind of move them all over here. So they're all going to commute to this side. And anything with letters and exponents, that's all going to commute to this side. And if you have different letters, different bases, your bases are going to want to commute next to each other, right? So that they can later on associate with each other, because you know that b squared times b to the 6th is going to simplify in just a minute. So what is that going to look like? Here's what we have now, 6 times 4 times b squared times b to the 6th. And we're going to get 24 times b squared times b to the 6th, which simplifies to 24 times b to the 8th, right? So b to the 6th times b squared times b to the 6th is b to the 8th. And that's just the same as 24b to the 8th. Okay. Key idea here, you can move around for multiplication only, right? We're going to learn about addition in a minute. You can do it for addition too, but not for division. This isn't for subtraction, it's for multiplication. You can move around the things, right? You can commute them around. So you can take this, you can put it over here, you can take this and put it over there. Why? Because the way multiplication was created, it's the same forwards and backwards. If I ask you what is 6 times 4, you tell me 24. If I ask you what is 4 times 6, you tell me 24. Because whichever order you multiply in, the answer is going to be the same. And that's the idea here, right? So essentially order doesn't matter for multiplication. That's basically kind of the concept. So we are going to use this commutative property. Let's practice. Ready, set, go.